Stop what you're doing. Look around you. You are about to witness the true, incomprehensible scale of one of the most fundamental numbers in the universe. This isn't theoretical physics. This is a simple question posed by Sean. What if we gathered a mole of moles? No, not the skin blemish. And not the spy. I'm talking about 602 sextillionaires of these small, furry creatures. An absurd, impossible number. But the science is crystal clear. If you took every single one and piled them up, you wouldn't just wipe out life on Earth. You would create a new, terrifying celestial body. A mole planet. And what happens next is truly gruesome. Before we talk about the animal, we must talk about the number. In chemistry, a mole is the official SI unit for the amount of substance. It's not a dozen, it's not a billion. It is a number so vast it's only relevant when counting atoms. As of the 2019 SI redefinition, the mole is no longer defined by the mass of carbon-12. Today, a mole is defined by the fixed Avogadro constant. 6.02214076 times 10 to 183. That number is the foundation of our impossible scenario. Now meet the creature, the eastern mole. Scalopus aquaticus. On average, it weighs about 75 grams. If you gathered one mole of 75-gram moles, you get one of the largest numbers in all of reality. The total mass is 4.522 times. Let's put that number in perspective with an escalating series of nightmares. The mass of our entire moon is 7.337 times 10 to over half our great celestial neighbor, replaced by a dark, wet pile of small, dead mammals. What if we release them onto the Earth's surface? Mammals, including moles, are roughly 70% water. Water, being mostly incompressible, gives us a clear volume calculation. 4.52 slope times 10 power 2 type kilograms of mole matter would initially occupy a volume of about 45,200,000 cubic kilometers. This fleshy ocean would displace all the air and cover every square inch of our planet, from the highest peaks to the deepest trenches, to an astonishing depth of 88 kilometers. That is well beyond the Kármán line, the edge of space. The sudden vacuum and the sheer crushing weight of organic matter would instantly and totally sterilize Earth. So we can't do it here. The only place big enough for this kind of catastrophe is space itself. Gathered in interplanetary space, the relentless force of universal gravity pulls the 4.522 times 10 due to the low density of biological matter compared to rock. This new object, the mole planet, would be slightly larger than the moon. Yet it would have only 1 temerns. As the sphere forms, the mass at the center begins to compress. The pressure rapidly reaches hundreds of megapascals. This pressure is so immense it would instantly halt all microbiological activity. The internal rot is stopped before it can even begin. Instead of decomposing into dust, the bodies are instantly compressed into a tight, oxygen-starved shell. The heat generated by gravitational compression and radioactive decay from trace elements in the tissue is trapped inside, insulated by what becomes a literal fur and flesh coat, a kilometer-thick layer of dead mole bodies. The interior of the mole planet becomes a hot, pressurized liquid core. Over thousands of years, the organic matter, mostly lipids and proteins, slowly breaks down chemically into a thick, black substance known as kerogen. If this planet were on a star's orbit, that kerogen would eventually form hydrocarbons. But here in the icy cold vacuum of space, something else happens. This hot liquid core is mixed with trapped gases, methane, carbon dioxide, and the air that was in the lungs of 6 convection currents. Like giant, slow-moving currents of liquid mole slurry drive this superheated, volatile mix toward the surface. The pressure builds until it finds a weak point in the frozen, furry crust. The result is cryovolcanism. Instead of molten rock, the mole planet erupts, blasting kilometer-high geysers of superheated, dark, organic matter, methane gas, and preserved fragments of dead mole tissue out into the void. A literal fountain of death, slowly releasing the planet's internal pressure over geological time. This isn't just a science fiction scenario. This is the calculated, gruesome end result of trying to measure the universe with the wrong scale. The Mole of Moles teaches us one thing. The sheer scale of the microscopic world is terrifying when applied to the macroscopic.